Hello, Year 11, and welcome to your first lesson on coastal management. Now, remembering back to your Barton on Sea trip, a lot of what we saw there is going to become very useful here, and hopefully anything you do remember will be make it easier for you. We're going to try and pinpoint exactly as we go through it what was in Barton as well, just to help you build on that prior knowledge you do have of that location. But before we start that, a quick look through here. I've picked on sand dune formation. Commonly one of the areas of the specification that students find perhaps a little bit trickier. So here are 5 statements. Each one of them has an error in them, a single word that I'd like you to correct. So copy the sentence out, but change the incorrect word. You've got 5 minutes to do that. Get cracking now. Pause the video. Okay, here are the answers in red. So the first dune to be formed is called an embryo dune. Vegetation helps to stabilize the sand dune, to hold it together. The oldest dunes are called grey dunes. Wind can form depressions called dune slacks that are often filled with water, and marram grass is well adapted to live on sand dunes and helps to stabilize it. So that 5th point links to the second one. Marram grass, an example of the vegetation. An easier way to remember the oldest dunes are called grey dunes as well is to think about hair. Think about what happens to people's hair as they get older. The oldest people have grey hair, so the same goes with dunes. That's why they're called grey dunes. Anyway, moving on, let's go. So copy the title down, please. Read through the objectives. You're going to need a pen today and a pencil. That is it. So get yourself sorted. Pause the video now. Okay, so a definition for you. Today we're focusing, as I said, on hard engineering, one particular type of coastal management. There is also soft engineering, but today we're focusing on hard. The use of concrete and large artificial structures by civil engineers to defend land against natural erosion processes. This stops nature from doing what it wants. It's saying, okay, this bit of coastline is being eroded. We're going to stop that. Longshore drift is occurring here. We're going to stop that. It's all about stopping nature. So copy that definition down. Take 1 minute. Pause the video now. Okay, so I'm just going to talk through the few different methods or strategies of coastal management that we're going to look at today. And then you're going to take some notes on them and start to evaluate them as well. So this is made from concrete, usually sea walls. It's a strong material, should withstand the high energy waves. It's impermeable, so it acts as a great barrier. It's usually at the foot of the cliffs or land that it's protecting, as in it's right up against it. And in this case, not all of them, but in this case, this is a curved sea wall. Notice the curved shape here. This means that any waves that attack this beach, this coastline here, well, they're going to crash into this seawall, but then be deflected back out to sea, which means all the energy goes back out to sea. Now, this is one reason why there isn't a beach down here, because all that energy comes back out and actually erodes away any beach in front. So that's a potential disadvantage of a seawall. It actually leads to the beaches in front of it being eroded away faster than they would otherwise be. However, it's an incredibly strong piece of coastal management and defense. Let's move on to the next one. Rock armor. So serves the same purpose as a seawall. It's designed to take the energy out of waves, except you'll notice it looks a little bit more natural. We're using natural rocks here rather than a big concrete wall. So these are large angular boulders at the base of a cliff to cause friction between the wave and the boulder, absorbing and removing the energy from them. So the land behind is protected. They'll have been brought here by a barge, usually on a boat, and deposited at the base of the cliff or land that needs protecting. One of the good things about this is quite easy to replace. A seawall, quite difficult to replace and maintain. You have to take whole concrete sections out and replace them with new big concrete sections. Here, new boulders can fairly easily be put back in place here. They can just be dropped in to wherever they're needed. It doesn't need mass improvements or maintenance, just the odd boulder popped in here and there when it's needed can maintain this quite nicely. Also, I mentioned in the last one that the beach at the base of the seawall is eroded. Here, these rocks actually, because they take the energy out of the waves, they lead to deposition. So the beach underneath them and in front of them is actually maintained because of these rocks. Let's move on to the next one. Groins. So I forgot to say, rock armor you've just seen, you saw at Barton. you saw rock armor at Barton. There is actually a seawall there, but it's hidden. Can't see it. It's underneath a rock armor and some beach. But we definitely saw groins, and we did our field work on groins. In the photo here, you've got some timber groins, some wood groins. We looked at stone groins. They are built out into the sea perpendicular at right angles to the coastline, and they help create a wider beach by stopping longshore drift. The beach acts as a buffer to the waves, reducing their impact. So the groins themselves don't take the power out of the waves, hence why they're facing the way they are. But what they do is create a larger beach, and it's the beach then that is used. So less hard engineering in a way, if you get what I mean. Still hard engineering. This is still stopping the process of longshore drift. But what we're not doing is building a huge big old wall across a whole beach. What we're doing here is actually using a natural beach to defend against it. However, you've got to argue they don't look natural at all, do they? There we go. So gabions, last one. These are cages filled with rocks. They are a fairly strong barrier, just like a seawall, just like rock armor, used to absorb the energy of the waves. Not the best looking, pretty unnatural looking, just like a seawall. Perhaps maybe a bit better than a seawall, certainly from a distance. One of the biggest disadvantages of these are that they can break quite easily. They're not as strong as the other ones, so after a big storm event, some of those cages may very well have been ruptured or broken, and then all the stones just fall out. It looks pretty ugly and loses its effectiveness. But anyway, it is certainly used, as you can see. So there we go, gabions, our final type of hard engineering. Right, I'd like you to read the 2 pages in the textbook, 106 and 107, and copy and complete that table. There is a copy attached to class charts, so you could just download it and print it if you can. If not, grab your ruler, grab your pencil, draw that table across a whole page. We want lots of space in there. The description row is describing what is a seawall, what is it made of, what does it look like, but also a little bit about how it works. The fact that in the case of a seawall, it removes the energy from the waves. Cost, is it particularly expensive? Is it a cheaper option? Advantages and disadvantages as well. So what's good and what's not so good about it, to help you evaluate each of these. Because ultimately, what I'd like you to be able to do is not just to tell me how they work, but also tell me, well, which would be better than the other one, to come to some form of decision. So get cracking with that. This will take you a bit of time, half an hour or so. So get cracking with that, and we'll come back in a minute. Pause the video now. Okay, I mentioned I'd like you to start thinking about making a decision. Well, here's your chance. So make a decision. Which strategy is the best? There is no right or wrong answer here. I personally couldn't care less which one you choose. But what you need to be able to do is argue effectively why that is the best. I think you should write P paragraphs to do that. Point, evidence, and explain. And you can see an example there. By all means, give that a read through. I'll let you read through that. Then I'd like you to write your own answer. Considering it a kind of 6-mark exam question. So at the very least 1 P paragraph, hopefully 2. So spend 5 to 9 minutes planning this, 6 minutes writing it. It should take about 15 minutes, and this will be at the end of the lesson. So get going with that by all means. Email your answer here to me. This is the kind of thing that would be great to see. Practice that idea of elaborating explanation as well. Use Barton on Sea perhaps as an example. We're going to have another example in a few lessons time that we can use, but by all means use Barton as well. Anyway, there we go. That is the end of the lesson. Have a great day. Take care, and I shall speak to you soon. Goodbye.